It's another learning day, everyone. Again, this is Teacher Marlene, and the focus of my discussion is about the inverse variation and try to discover the difference of inverse variation with direct variation. Now, how will describe inverse variation? If two variables, x and y, are so related that their product is constant, or k is equal to x times y, then y is inversely proportional to x. We can denote this into symbols such as y is equal to k over x. If we put this into graph, we will observe that if one quantity increases, the other quantity decreases. Or vice versa, if one quantity decreases, the other quantity increases. Have you experienced playing in a seesaw? If you tend to goes up, then your playmate goes down. On the other hand, if you goes down, your playmate goes up. This relationship showed inverse variation. Let us practice translating the following phrases into symbols. Are you ready? The volume of a gas at constant temperature varies inversely with the pressure. If V represents volume and T for the pressure, how will you write this into symbol? It should be V is equal to K over P. Now let us try another one. The time required to travel a given fixed distance is inversely proportional to the speed. Can you write the symbol? Yes, it is T is equal to K over S. How about this? For a given distance, the required time varies inversely as the rate. So what is your answer? It should be T equals K over R. Did you get it correctly? Let's give a clap. Now, how will you determine if the table is a kind of inverse variation? Now look at the table below. The two quantities being compared are the speed or rate and the time. The rate varies inversely as time. So the constant of variation represented by k is obtained by multiplying rate and time. Let us find k. So k is equal to 40 times 1, which is equal to 40. 50 times 4/5 can be solved by dividing 50 divided by 5, which is 10, times 4 is equal to 40 also. The same with 60 times 2/3. 60 divided by 3 is equal to 20, times 2 is equal to 40. Then 70 times 4 over 7, 70 divided by 7 is 10, then times 4 is 40 also. And lastly, 80 times 1/2, 80 divided by 2 is 40, times 1 is 40. So the rate times the time are all equal to 40. We can say that the rate varies inversely as the time. In symbol, R is equal to K over T. So the equation of variation is R is equal to 40 over T. Now let us solve the following problems. Our first problem is, if y varies inversely as x and y equals 1/2 when x is equal to 4. Find x when y equals 1/4. First, let us translate the statement, if y varies inversely as x, into symbols. So it is y equals k over x. Using y equals 1/2 when x equals 4, let us solve for the constant of variation. By substitution, 1/2 is equal to k over 4. Now let us apply the cross multiplication. 2 times k, which is 2k, and 1 times 4, which is 4. So 2k is equal to 4. Now let us divide both sides by 2. So the value of k is 2. This is the constant of variation. Using k is equal to 2, substitute in the symbols to get the equation of variation. So y is equal to 2 over x. Now let us find x when y is equal to 1/4. Substituting y equals 1/4, we will get 1/4 is equal to 2 over x. Then cross multiply. 1 times x equals x. 4 times 2 equals 8. So x is equal to 8. This is the task in the problem. Now let's take a look at another example. For a given gas of constant temperature, the pressure varies inversely as the volume. If P equals 6 when V equals 24, find P when V equals 36. Using the statement, pressure varies inversely as the volume, we can write the variation symbol into P equals K over V. From the symbol, let us substitute P equals 6 when V equals 24 to find the constant of variation. It becomes 6 is equal to K over 24. Let us change 6 into fraction by putting over 1. Now, let us apply the cross multiplication. 1 times k, which is k, and 6 times 24, which is 144. So k is equal to 144. This is the constant of variation. Then using the constant of variation, we can write our equation into P is equal to 144 over V. Now we can find P when V equals 36. Substituting V equals 36, we will get P equals 144 over 36. Or 144 divided by 36 is 4. So P is equal to 4. Let's analyze the next problem. Find the number of days 10 workers can complete a job if 5 workers can complete the job in 7 days. Remember this? The more people doing the work, the lesser time to do it. Have you experienced this in doing household chores or doing a group project? If each member of the family or group member are doing the task will be finished in a shortened span of time. We can restate the problem this way. The number of days a job can be completed varies inversely as the number of workers. So we can easily change this into symbol, which is D equals K over W. Using the statement 5 workers can complete the job in 7 days, substitute this given to find the constant of variation. So 7 is equal to K over 5. Put 7 into fractional form. Then cross multiply. 1 times K is K. And 7 times 5 is 35. So the value of K is 35. This is the constant of variation. So using K equals 35, our equation is D equals 35 over W. Now, we can answer the problem to find the number of days 10 workers can complete a job by substituting 10 in W, so 35 over 10, which is equal to 3.5. So 10 men can finish the work in 3½ days. That's all for today's discussion about inverse variation. What you put in mind, as one increases, the other decreases. Similar to life's lesson, be humble and God will raise you up. God bless everyone. Happy learning!